To decide which is a tertiary alcohol, we're going to need to draw the structures of all of these compounds first. These are the structures. Butan-2-ol is that one. 2-methyl-pentan-3-ol, that one. Propan-1-ol. Ethane-1,2-diol. 3-methyl-propan-2-ol. And propan-2-ol there. To be a tertiary structure, tertiary alcohol, you need to have the OH group attached to a carbon which has 3 alkyl groups attached to it as well. And this is the structure that meets that criteria. So the answer is 2-methyl-propan-2-ol. The skeletal formula of this structure, which is this one over here, is as follows. The 5 carbon atoms in the straight chain are here. The side branch is here on the number 2 and the OH group is on number 3. The structural isomers of these two compounds are here, 4 carbon atoms, and here. So this will be our answer. A third isomer of these two alcohols would be quite similar to this version, except the OH group would be on the end. It'll be called butan-1-ol. The last question is about ethane-1,2-diol, and that would be this molecule here. The solubility of this compound comes from its ability to use the OH group, the alcohol group, to hydrogen bond with adjacent water molecules. And you might show this in this kind of diagram as well as writing about it. This question talks about reacting ethanoic acid, which is here, with ethane-1,2-diol. You will get a reaction across these atoms to form an ester, but the trick is to notice that the formula has 6 carbon atoms in it, so the same process is going to happen at the other end of the molecule. So this is the final structure, and you'll have 2 ester linkages in this molecule. In this question, butan-2-ol is dehydrated when heated with sulfuric acid. Dehydration will form a double bond here or there after a water molecule has been removed from these positions. Only this version will form EZ isomers, since these two things are different on each carbon atom. So these are the stereoisomers, and this is the E version and this is the Z version. This type of isomerism is geometric isomerism, and in the last question the other isomer that they asked for is this one, drawn in this space. In this question, one of these 6 alcohols is oxidized with this reagent, and we know that the molecular ion peak gives a value of 60, and that this carbonyl peak at around about 1700 is present when you oxidize the alcohol. The OH peak, look, has vanished. Looking at this piece of information first, we can eliminate any tertiary alcohols because they are not oxidized. We can also eliminate any primary alcohols. They would be oxidized, but they would give carboxylic acids, so we'd expect to see a peak here and a peak here for the OH group in the carboxylic acid. When we consider the 3 remaining possibilities, what we need to do is compare the molecular mass to the molecular ion peak, and that brings us down to one final choice. It must have been propan-2-ol. The other alcohols would have given a much higher molecular mass than 60. Propan-2-ol is a secondary alcohol, and secondary alcohols are oxidized but only into ketones. So this carbon atom would have reacted by losing hydrogen and becoming this ketone group here. So this is propan 2-one. All of this information would need to be summarized on the next page of this question. The only thing you would need to add is the equation for the oxidation reaction. This is the equation, and these two hydrogen atoms join with this oxygen atom from the oxidizing agent to form water. What's left is the ketone. This question is about ethanol and infrared spectroscopy. You're asked to identify particular absorption bands for ethanol, so you're really going to be looking at this part of the molecule and this part of the molecule in a data table like this. This table is from a different exam board, but we can see that the OH absorption band is here and the CO absorption band is here. For the second part of the question, we should remember that dichromate ions are orange initially and then react to become green afterwards. The equation for the reaction of ethanol is that of a primary alcohol with an oxidizing agent, so it will become a carboxylic acid. Just a quick reminder, these two hydrogens will be lost to become water molecules, and oxygen is needed for that. The remaining oxygen atom becomes part of a carbonyl group within the whole carboxylic acid group. And to make the number of oxygen atoms balance on both sides of the equation, we have 3 there and now 3 here. For this question, we have an IR spectra and a mass spectra fragmentation pattern for an organic molecule. At the moment it doesn't make much sense to us, so we need to look at what the questions are asking about this data. So, part 1 asks us to consider the evidence for the fact that this organic molecule could be just a simple hydrocarbon. We need to identify that the fact has this formula by looking at the molecular ion. Once we know that it is in fact C4H10, we can draw the various structural isomers. Finally, we can also look at the fragments in the mass spectra, compare them to the kind of fragments we're going to get in these isomers to see which is the most likely possible match. If you go back a little in this video, you'll see in the previous question that this band in the IR data table was attributed to CH bonds, and there are no other big absorption peaks present. So this is in fact our evidence that this is a simple hydrocarbon. The most useful piece of data from a mass spectrum is the molecular ion peak at the furthest right hand edge of the spectra. In this case it looks like it's on 58, and this does correspond to C4H10. The fragments in this part of the question will come from these two molecules, so you have to think which structure is most likely to give a mass fragment of 15, 29 and 43. Both molecules will give methyl fragments from here and here. But only this molecule would give a fragmentation pattern of the correct mass to match what's given in the question. The last missing chunk can come from either molecule that's here or possibly here, and would be written in this space. All of those individual findings would need to be written out in these spaces, and your summary as to why you chose the final isomer in that space there. This would have been 2-methyl propane rather than butane.